Let S be set of all passwords. What are these passwords? These passwords can be 6 to 8 characters. Password can be of length 6 or 7 or 8. Now, each password can be made using this alphabet, 5 letters of this alphabet, that is A, B, C, D, E, or one of letters from 1, 2, 3, 4, 5. And repetition of characters is allowed. That means six characters. Either you can take all letters, all numbers, or a combinations of letters and numbers, and you can repeat letters and numbers. Now, if the number of passwords in is whose at least one character is number is alpha into 5 power 6. One character is number, right? Then how many such passwords are there? How many passwords of 6 to 8 characters such that one character is at least one character is a number, right? So we can have three kinds of passwords. One is 6 characters, 7 characters, and 8 characters. Now, if these 6 characters, if what are the total passwords that can happen? Right, we have 6 characters. 1, 2, 3, 4, 5, 6. Each 6 we can have this 5 and this 5. Right, each 6 we have 10 options. 10, 10, 10, 10, 10, 10. Right, we can choose either one of these 5 letters or one of these 5 digits. So we have total 10 options for each of the letters. So in total we have for 6 character passwords we have 10 power 6. 10 into 10 into 10 into 10 into 10 into 10. That is 10 power 6. Similarly for 7 character passwords we have 10 power 7 passwords. These are the maximum number of passwords that are possible. Similarly for 8 characters we have 10 power 8 passwords. Now let's say we want to create passwords 6 letter passwords with only letter passwords. Right, that means we will not use numbers. All these 6 places we will use only letters. How many options we have? For each space we have 5 letter options, right? 5 into 5 into 5 into 5 into 5 into 5. Right, for each letter we have 5 options. So that's why 6 character passwords using only letters will have 5 power 6 such passwords. Similarly, 7 character passwords we have 5 power 7, and 8 character passwords using only letters we have 5 power 8. What does that mean? The total passwords minus only letter passwords will give us all the passwords which will have at least one number. Right. So only 5 power 6 passwords will have all letters, and whatever beyond this 5 power 6 within this 10 power 6 means all of those passwords will have at least one number. They can be more numbers or it can be all numbers, but at least one number, because we are removing all the passwords which are only letter passwords, right? So that means this set that we are talking about, that what is that? That is 10 power 6 plus 10 power 7 plus 10 power 8 minus 5 power 6 plus 5 power 7 plus 5 power 8. And what is 10 power 6? We can write it as 2 power 6 into 5 power 6. 10 is 2 into 5. Similarly, 2 power 7 into 5 power 7, 2 power 8 into 5 power 8. Right, now let's take this 5 power 6 common, because in the answer it is given something into 5 power 6. So let's take this 5 power 6 common. Here we'll be left with 2 power 6. He will be left with 2 power 7 into 5. Here we'll be left with 2 power 8 into 5 square. Right. 5 power 6. If you remove 8 minus 6, 5 square will be left. Minus 5 power 6. Because we are taking 5 power 6 common, so minus 1 and minus again 5 and again 5 square. We are taking 5 power 6 common. Right. Now what does that mean? That means if you simplify this is 5 square minus 5 minus 1. That is 25 minus 5, 30, and minus 1 minus 31. Fantastic. Now, what exactly is this? This is 2 power 6. Right, 2 power 6 plus again 1, 2 if you bring it here, 2 into 5 that is 10, 10 into 2 power 6. Again here also 5 square 25, 2 2's if you bring it here, that becomes 4 into 25, 100, 100 into 2 power 6 again. So 2 power 6 into 10 into 2 power 6 plus 100 into 2 power 6 minus 31. What does that mean? 2 power 6 into 100 plus 10 plus 1, that is 111. 2 power 6 into 111 minus 31. What is 2 power 6? It is anyway 64. 64 into 111 minus 31 into 5 power 6. So what is our alpha? Alpha is actually 64 into 111 minus 31. So that is 70, 73. That is the answer. Right, guys?